Okay, so last lecture we learned about chemical equations and how they can be used to track changes in matter. What we're going to learn in this lesson is about observing those changes in matter. So let's choose a color. I don't know, I'm in sort of purple mood. All right. Oh, too far. So chemical equations. Remember, I'm doing the EQN apostrophe S for equations. No period there. Contain information that you can use to predict what you might observe in that reaction or change. So an example of this would be if this was your chemical equation, and now this is a very simple chemical equation, but if this were your chemical equation, what would you expect to see? Well, very simply, you would expect to see a liquid turning into a gas. So you have a liquid reactant and you end up with a gaseous product. More specifically, you would expect liquid water, H2O, to boil and turn into steam. So by looking at this, you can predict what you might observe. Now, sometimes change is described by more than one chemical equation. Sometimes change can be described by more than one chemical equation. Now, whoops, that should be, yeah. Things are generally not as simple as we describe them in our chemistry class. Sometimes they're a lot more complicated. So, chemical equations allow you to track reactions on an atomic level. So we're not able to see necessarily what's going on the atomic level. We can see things changing phase, but we can't see what's happening at the atomic level. So this is going to help us understand that. And there are pieces of information not described by chemical reaction. By chemical equations. And that would be things like color or mass. Those things can't be described by a simple chemical equation. Now, there are three levels of understanding of chemical equations. So the first is macroscopic. And this is things we can observe directly. Things we can see. Macro means big. So macroscopic is things we can see on our level. So this would be things like state, color, smell, temperature, sounds, etc. Things that we can observe directly. Next would be submicroscopic. So we know microscopic, it would be small. Submicroscopic is even smaller than small. This is what's happening between the particles that are involved. In this case, it could be, in any case, it could be ions or atoms or molecules. And this would be the making and breaking of bonds. And then there's the symbolic. So this would be our writing of chemical equations. Oops, that should be Q. To describe change. And we're going to start combining actually the submicroscopic and the symbolic in particulate representations. All right, so that's the three levels that we will be using to understand chemical changes, or changes in matter, more specifically. So how can you predict what you observe based on a chemical equation? Well, chemical equations allow chemists to predict and track changes in matter. So they indicate how many products, what those products are, the phase of each product, and what we're going to find out later is they're going to tell us the ratio in which those products react and are formed. And observations provide information not covered by a chemical equation and vice versa. So observation alone can't tell you what substances are present. So there needs chemical equations can help you predict what it is that you actually are seeing when that happens.